Hi Algebra! So far we have been solving systems of equations by graphing and then by substitution. Now we're going to solve them using elimination. So we have another tool in our toolbox. Here we go. We are skipping ahead to 14.2, adding equations. We have Diego again. He's solving this system of equations. He has some work here and here. I want you to look through his work and make sense of it. Discuss it with a partner if you're doing this video with someone, and then answer A and B before you move on. To look more closely at Diego's work right here, it looks like he took his first equation and then added it to his second equation. We see this plus sign right here. When he did that, he got rid of his x's and he ended up with 8y equals 16, and he could then solve that to figure out one piece of the puzzle, or he could figure out y. Now, why can he do this, right? Well, remember when we are working with equations, you have to add the same thing to both sides. Well, we already know that 6 is the same thing as all of this because of this equal sign. So when he adds 6 over here and all of this over here, he is adding the same thing to both sides because both sides of that equation are the same. But it's really helpful because now he's down to a simple equation that he can solve. Then he went over here and plugged in 2 for his y and figured out his value for x. We call this process that Diego did right here elimination because he eliminated a variable. He got rid of the x's, which made it easier to solve for the other variable. So does Diego's method work for solving these systems? So let's look at A first. And here, if I add these together, I would actually write it with a plus sign right here. And I'm adding them together, so I'm going to end up with 3x plus 0y equals 15. So I got rid of my y. I can just rewrite this as 3x equals 15. And so I'll know that x equals 5. So I've eliminated a variable, figured out what x is, and now I can go back up here, plug that in somewhere. I could pick this equation, it might be easier, and figure out what y would need to be. So I would have 5 for x minus y equals 11. And I'm going to subtract 5 from both sides. I have negative y equals 6. Divide both sides by negative 1. So I end up with y equals negative 6. So as an ordered pair, I write my answer as 5 comma negative 6. So Diego's method of elimination did work really nicely for this equation. For B, if I add these equations, I would end up with 16x plus 12y equals 44. So it did not eliminate a variable for me, but we do have other options. Instead of adding equations together, we could subtract. So I could subtract this whole equation from the first one. And you just have to be really careful with the negatives when you do this. So I have 8 minus 8x, so that would be 0x, plus, remember here I'm subtracting y, so it would be 11y minus y, so that would be 10y, equals, remember over here it's 37 minus 7 equals 30. So I could rewrite this as just 10y equals 30, so I know that y equals 3. I took 3 for y, plugged it back into this second equation. It just seemed a little bit easier to use. And when I did that and solved for x, I got x to be 1/2. So as an ordered pair, my answer would be 1/2 comma 3. So the method Diego used of adding the equations didn't work for this one, but we can also subtract equations in order to eliminate a variable. When you do this, you just have to be really careful with those negatives. In 14.3, we're just verifying why elimination works to solve these systems. So in system A right here, I've added the two equations together to get that third equation. We saw Diego do that before. And I've put each of these equations into Desmos. And I know that the solution to a system of equations comes where they cross. Now this third equation that we get when we added them together is right here, this green line, and notice that it also crosses at the same point. So elimination works because it's still giving us the same solution as the other two equations. Turning to your lesson summary in lesson 14, there's a few things here that is important. First is this idea of elimination. So we want to eliminate a variable so that we can solve for the other one. And we're going to do that by adding or subtracting equations in the system. And they give you a really nice example right here, and then they work through it down here. So use that as an example as well, in addition to the examples that we did in the lesson. In lesson 15, we're going to continue solving by elimination and get a little more practice with it. In lesson 15, we are skipping to 15.3, a bunch of systems. In A, I'm noticing that I have a positive 2x and a negative 2x right here, and so if I add those together, I will be getting rid of the x's. So try doing that and solving for y. So I figured out that y equals 3. Now I'm going to plug that into one of the equations up here. I'm going to choose the top one just because there's no negatives, and sometimes negatives can cause mistakes. So instead of y, I'm going to plug in 3, and I'll finish solving this for x. When I did that, I got x equals -1. So writing this as an ordered pair, I would have -1, comma 3. And just as a reminder to check your work, you could plug in -1 for x, 3 for y into both equations, and it should make both equations true. You could also graph both of these equations, and where they cross would be that point. When I added the two equations together, I got 5x equals 10, which means that x equals 2. So I plugged 2 in for x. I used the first equation here because there were no negatives. And when I solved that for y, I got y to be 1. So as an ordered pair, this would be 2, comma 1. Looking at C, if I just add together my equations, I'm not going to end up eliminating a variable. But I notice that if I subtract the entire second equation, I will get rid of the x's. So again, I just have to be really careful here. 2 minus 2x would be 0x. 3 minus 4y would be -1y. And 5 minus 9 would be -4. So I could rewrite this as -y equals -4. When I solve this for y, I'm going to divide both sides by -1. I get y to be +4. When I plugged 4 in for y, I used the top equation. Again, you could use either one, but I got y to be -3.5. So as an ordered pair, I would write this as -3.5, comma 4. And again, if I graphed it, that would be the place where those two cross. In D, no matter how I add or subtract these, I will not end up eliminating a variable. But I do notice that if I took my first equation times 3, then I would have 6x in both of them, which means I could subtract to eliminate a variable. So this is kind of going to our next step in elimination, but let's just try this out. Let's take our first equation and we're going to multiply everything in it by 3. So I'm going to rewrite that as 6x plus 9y equals 48, because I have to multiply both sides by 3. And then my other equation would just stay the same. Now, if I subtract off the entire second equation, I would have 0x. Be careful here, 9 minus a -5y. That would be like adding 5, so that'd be 14y equals, and then I'd have 48 minus 20, so that would be 28. I could rewrite it like this, and I could divide both sides by 14. I end up with y equals 2. And now I could substitute that in for either equation. I'll do the first one, and then I could solve for x just like usual. And when I do that, I get x to be 5. So this would be my ordered pair for my solutions. Now, this idea of multiplying is a little bit beyond what we're doing right now with solving a system of equations by elimination. This goes into our next lesson, which is a should do lesson. So if this idea of multiplying to be able to eliminate a variable doesn't seem so bad for you, or you just want to learn more, then go ahead and do the next lesson, which is a should do. All right, nice job solving these systems by elimination. You now have 3 different ways to solve systems. You can graph them and find the point where they cross. You can use substitution, or you can use elimination. So you have lots of tools in your toolbox, and use whatever works best for the system that you're given. Nice job, guys.